Welcome to our video module on fractional design, where we're continuing our discussion of foldovers, generators, defining relations, and other aspects associated with fractional design.
And today we'll be looking specifically at blocking. Now, for those of you who are paying attention, I had mentioned that if we were doing a foldover, we might run these 8 runs, and then we might be interested in separating out this main effect. But if we do that, then it's not fully random. We're doing it once with 8 runs, and then we're doing it a second time with another 8 runs. So this brings up the idea of blocking, and precisely which interactions are confounded with these blocks. Today we'll be outlining the simple rules that are used for understanding the interactions that are aliased with blocks when we're doing a foldover design. So to start with, let's pretend that we're doing a full foldover. And here, the full foldover we outlined was this lowest alternate fraction, where both D and E effects were negative instead of positive. And in doing so, we're confounding some of the interactions with the blocks. Fortunately, the way to find it out is really easy. All we do is we take each of these generators and we multiply it by the defining relations. So ABD times ABD, well, that's just going to be 1, right? But ABD times ACE, that's BCE.
Well, let's pause that right there. No, it's not BCE, it's BCDE, it's the third term, it's the generalized relation. My mistake on that. Please forgive me as the video continues.
ABD times, see what we're doing? ABD times BCDE, let's see, would be ACE, which is this one right here. And likewise, we're going to take ACE times each of these. So ACE times ABDE is BCDE. Of course, ACE times itself is just, whatever, 1. And then finally, ACE times BCDE is going to be AB. This gives us the interactions that are confounded with the blocks, because we will have to use this generally in 2 different time frames or in 2 different materials, whatever it is. We will need to block this setup when we're either doing partial or full foldovers. Likewise, if you wanted to do a partial foldover, you do the same thing with simply the generator, let's say D equals AB. You'd multiply that by each of your defining relations. Now, of course, in this case, we have such simple defining relations. There's only 3 of them that we're not going to see anything remarkable happen here. But one can imagine if we were, say, doing 2 to the 8 minus 2, our defining relations are much more extensive. I hope this gives you the quick tools you need to outline blocking in either a half fractional or quarter fractional design when foldover is included. Thanks for joining me. Take care.